TSE Physics 2015 structure question 1. So now we are using a resistance thermometer to measure the temperature. In the graph, it shows the actual resistance of the metals inside the resistance thermometer and our calibration line. That is, in our calculation, how do we think the resistance varies with temperature. So the metallic resistance, this is the actual variation. So it's accurate. For the calibration line, it's for our calculation. And it is inaccurate. Okay, firstly, part A1. Using the resistance given in the table, where at 0 degree resistance is 102, 100 degree resistance is 140. So we have two fixed points, and we think they varies linearly with temperature. That means we think that the resistance will be a straight line variation with temperature. So we can use the formula for thermometer. We can use R minus R0 over T minus T0 equals R100 minus R0 T100 minus T0. So let's put in the numbers. R is the unknown resistance that we have to calculate. So R0 is the resistance at 0 degree, 102, over unknown temperature, that is 60 degree. T0 means 0 degree, lower fixed point. So R100 means the resistance at 100 degree, that is 140.51. R0 is 102, we just talked about that. So 100 minus 0. So after solving the equation, we would find that the resistance at 60 degree would be equals to 125.1 ohm. Part 2. Now if the resistance of the resistance thermometer is the value found in A1 is the actual temperature higher than, lower than, or equal to 60 degree. What does that mean? This means, let me enlarge it. Okay, so this means that we thought that at 60 degree Celsius, when we comes up from here, okay, we will look at the calibration curve. We think that the resistance will be this much. So we'll read the resistance and we find it to be 125.1 ohm. However, as we have emphasized that the actual variation of resistance does not follow a straight line as we thought. The highlighted curve is the actual variation of the resistance. So now let's say if the resistance is really 125.1 ohm as we have calculated, then what should be the actual temperature? We should read like this. So the resistance is 125.1 ohm. So actually, according to the actual variation, it should come to this point. And what should be the temperature? We can read it by drawing a straight line here. So that means if the resistance is 125.1 ohm, the actual temperature should be 40 degree, not 60 degree. Therefore, if the resistance of the thermometer is the value found in A1, that is 125.1 ohm, if this is really the resistance, the actual temperature will be lower than 60 degree. It's approximately 40 from the graph, as we have read from the graph. So part B. In an experiment to determine the specific heat capacity of water, so this thermometer is used to measure the temperature from 0 to 60. So heating was stopped when the thermometer's resistance reached 125.1 ohm. So because Peter thinks that this is 60 degree lah, okay, so he stopped the experiment. So no heat change with the surroundings, no heat loss to the surroundings, no error in the measuring the energy supply, okay, and the mass of water. Whether the experimental value of CW is higher than, lower than, or the same as the actual value. Okay, so now the resistance is 125.1. Peter thought the temperature is 60 degree. However, the temperature is actually lower than 60 degree. Therefore, the actual temperature difference is less than 60 degree. Delta T measured, Peter thought it has rise for 60 degree. However, the actual rise in temperature is less than 60 degree. So the measured delta T would be larger than the actual. Assuming Q is measured correctly, M is measured correctly as the question stated, this will lead us to the measured specific heat capacity of water to be decreased, to be lower. So therefore, the measured seawater is lower than the actual value.